Let's go ahead and work on homework exercise number 12, 13, 14, and 15 from section 5.1. Homework exercise number 12 states a relief worker divides 360 bottles of water and 96 cans of food into groups that each contain the same number of items. Also, each group must contain the same item, bottled water or canned food. What is the largest number of relief supplies that can be put in each group? And notice each group must contain the same type of item, so you can't intermingle water and food. So basically, if you've got 360 bottles of water and you've got 96 cans of food, you want to find the largest number that can be put in each group without having a remainder. And basically, that's the number that goes, the largest number that divides both 360 and 96. So that is simply the greatest common divisor. Okay? So again, so we can go ahead and we're going to just go ahead and we can use our calculator easily to get the greatest common divisor, which will be our answer. So we can go ahead and do that on our calculator by going to the math key and then using the right arrow to go from math to highlight numbers. And then if we scroll down to number 9, it's the GCD. When we highlight that, we hit enter, and then we can put in the first number and then a comma, which is above the 7, and then the second number, and then you don't even need a right paren, and go ahead enter, and it gives us our greatest common divisor. So in this case, 24 would be the largest number that could go, that would divide both of the largest number that would divide both of the relief supplies evenly. Now again, if you don't have a TI-84, 83 calculator, you got to do a pencil and paper. You got to do the prime factorization. 360 is 2 times 180. 180 is 2 times 90. 90 is 2 times 45. 45 is 5 times 9, and 9 is 3 times 3. So 360, the prime factorization would be 1, 2, 3 2's. So 2 to the 3rd power times 3 squared, 2 3's, times 5. 96 is prime factorization 2 times 48. 48 is 2 times 24. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So we got 1, 2, 3, 4, 5 2's. So 96 is 2 to the 5th power times 1 3. And now remember, the GCD is the factors that are in both, the common factors. So greatest common divisor, they both have 2's and 3's, and you take the smaller exponent. So 2 cubed is the smaller exponent. 3 here is just 3 to the 1st, which is smaller than 2, so it's 3 to the 1st. So 2 cubed is 8 times 3. 8 times 3 is 24, which is the same correct answer we got using the calculator. Okay? So definitely want to use your calculator if you've got that. It makes it a lot easier. But if you don't, it'll just take you a couple extra minutes to do it. Let's look at number 13. You have in front of you $295 bills and 260 $10 bills. Your problem, place the $5 bills and $10 bills in stacks so that each stack has the same number of bills and each stack contains only one kind of a bill, 5 or 10. What is the largest number of bills? Again, you're trying to divide evenly 290 and 260 so you don't have any left over, and you got to keep the same number. You can't intermingle. So again, it is the largest number that divides both, which is the GCD, okay? So this answer, again, is very similar to number 12, just different words, but the same concept. So it's the GCD of these two numbers, 290, and 260. So again, if you use your calculator, you can go ahead and do math, right arrow over the numbers, down to number 9, GCD of 290, comma 260, and we get 10. Again, you can do the prime factorization of each of these numbers, and then you would pick the common factors with the smaller exponent if you did it pencil and paper. Let's look at number 14. You and your brother both work the 4 p.m. to midnight shift. You have every 4th night off. Your brother has every 8th night off. Both of you are off on May 1st. Your brother would like to see a movie with you. When will the two of you have the same night off again? Now, in this case, we're looking at multiples, right? You have every 4th night off. So you have the 4th, 4 times 1 is the 4th night off. 4 times 2 is the 8th night off. 4 times 3 is the 12th night off. Your brother has every 8th night off, so 8 times 1 is equal to 8. Now notice, this is the same night, right? It's going to be, because you have 8 nights after, and so does he. So actually, we're looking here at just the least common multiple, but the numbers were so small, we just kind of did it by pencil and paper, and we easily got our answer. Now notice, it's 8 days after you were both off on May 1st. So 8 days after May 1st would bring us to May 9th, right? 8 days later would be May 9th. Now, so that would be the correct answer. Again, we're just finding the least common multiple. Okay. May 9th, which indeed is the correct answer. On the calculator, you would just go ahead and do math, numbers, least common multiple is number 8. Went too fast, you can just backtrack. Hit enter, and 4, 8, and the least common multiple is 8. Two people are jogging around a circular track in the same direction. One person can go completely around the track in 33 minutes. The second person takes 63 minutes. If they both start running in the same place at the same time, how long will it take them to be together at this place if they continue to run? Now again, what we're doing here is we're doing multiples, right? You're completely around the track in 33 minutes, so 33 times 1 is 1 loop. 1 lap would be after 33 minutes. 33 times 2 would be 66, and so on. The second person's 63, so 63 times 1, 63 minutes. 63 times 2 is 126. So we're looking for the least common multiple. Now again, we don't have a common multiple. We don't have to keep on doing multiples. We can do it by the prime factorization. And then you have the rule. So let's go ahead and do it that way. You have 33 minutes, which is 3 times 11. That's the prime factorization, right? 33 is 3 times 11, and 63 is 9 times 11, and 9 is 3 times 3. So 33, the prime factorization, is 3 times 11. 63 is 3 squared times, I'm sorry, 63 is, I'm thinking of 11. 63 is 7 times 9, and 9 is 3 times 3. Got to learn my multiplication table. All right. No, whoa. Yes, 63 minutes. Okay, 63 minutes is 7 times 9. 9 is 3 times 3. Okay, so is that better? So again, the prime factorization of 63 is 3 squared times 7. The 3's and the 7's are the primes. Now, the rule for the least common multiple is you put all the factors in, either if it occurs in both or one. So we have a 3, we have a 7, and we have 11, and you take the larger exponent. So 3 to the first and 3 squared, we take 3 squared. There's only one 7 here, so we take one 7. There's only one 11 here, so we take one 11. So 3 squared is 9 times 7 times 11. Again, we can at least do that on our calculator, 9 times 7 times 11. And we can go ahead and do the multiplication. 9 times 7 times 11. And we get 693 minutes. All right, now on the calculator, there's also the least common multiple. So you can go to Math, over to right arrow, highlight, so numbers is highlighted. Scroll down to, I believe it's number 8, and LCM, and the first number is 33, a comma, the second number is 63, hit enter, and there's our answer, 693. Same answer we got doing it pencil and paper. This concludes this video, and this concludes the problems from section 5.1. If you have any questions, email me at tswierzz, tswierzz @hodges.edu, or call me at my office, 239-938-7805. Thank you.